Have you ever imagined your home could supply almost all of its own energy without depending on the power grid? This is not a distant dream, but a reality being brought to life by an ancient spiral technology. Welcome the Archimedes Wind Turbine, a design that breaks every traditional renewable energy rule you have ever known. In a world struggling with escalating energy costs, this solution offers hope for true independence. The figure of 92% energy self-sufficiency is not an advertisement, but the result of a perfect blend of wind and solar. To understand why this device is so superior, we must travel back in time to ancient Greece over 2,000 years ago. The genius Archimedes invented a spiral screw to transport water against gravity. Originally, it was designed to pump water out of the massive ships of King Hiero II of Syracuse. For millennia, this principle has helped humans with irrigation and drainage in deep mines. But in 2003, a Dutch inventor named Marinus Miramet came up with a wild idea. Instead of using a rotating shaft to push fluid, what would happen if we let air push the shaft? Miramet discovered a gap in Archimedes, surviving mathematical works regarding the spatial potential of spirals. He transformed the Archimedes screw into a three-dimensional conical spiral optimized for turbulent urban winds. This was the birth of the Liam F1, a device shaped like an artistic nautilus shell. Why do traditional three-blade turbines struggle in crowded city environments? Standard turbines rely on the principle of lift, similar to an airplane wing, requiring steady and fast airflow. Meanwhile, wind in urban areas is often disrupted by buildings, creating turbulent and constantly shifting airflows. When wind direction shifts, heavy turbines must consume energy to yaw the body toward the wind, severely reducing efficiency. The Archimedes turbine addresses this problem with its own magical geometry. Its structure consists of three circular blades wrapped around each other, expanding along a horizontal axis, following the Fibonacci sequence. Instead of creating a pressure differential on a thin blade surface, it utilizes the entire spatial volume within the spiral. As wind enters the front, the conical shape forces the air to accelerate along the blade surfaces and redirects the flow by 90 degrees. This process allows for the extraction of a massive amount of kinetic energy from even the weakest winds. A unique mechanical property of this design is its ability to self-orient to the wind without sensors or motors. Thanks to aerodynamic balance, the turbine always finds the optimal wind direction in an instant. This completely eliminates mechanical stress and energy waste common in older devices. Omnidirectional tolerance is a major plus, as it can capture wind at an angle of up to 60 degrees from the main axis. While other turbines stall, the Liam F1 continues to spin steadily in the swirling air above rooftops. Its cut-in speed is also incredibly impressive, requiring wind at only 5.6 miles per hour. Most turbines of a similar size need double that wind speed just to start generating the first watts of power. The efficiency of this design reaches about 80% of the Betz limit, an extremely high figure for small-scale turbines. Independent tests at Pusan National University in South Korea confirmed its durable operating capabilities. Even in severe storm conditions on the Incheon coast, the turbine remained stable without structural damage. But what amazes many people most is the absolute silence during full-capacity operation. Three-blade turbines often create an annoying rhythmic thumping as the blade tips cut through the air. The Archimedes design has no blade tips, so the noise level is below 45 decibels, equivalent to light rain. You can stand right under the turbine and have a normal conversation without being disturbed. For birds and bats, this turbine is also much safer than traditional devices. Fast-rotating blades of traditional turbines often create a blur that birds cannot perceive as an obstacle. In contrast, the Archimedes spiral is a solid three-dimensional entity moving at a low angular velocity. Birds can see it as a large object and easily fly around it to avoid collision. Throughout a decade of testing in the Netherlands, there have been no reports of bird strikes by this type of turbine. So if it is so good, why do we not see them on every rooftop right now? The answer lies in the economic puzzle and complex technical installation barriers. A Liam F1 turbine costs between $5,000 and $7,000, a significant investment. With average urban wind speeds, the payback period can stretch to over 20 years. Compared to solar power with a payback period of only 6 to 8 years, the financial choice becomes obvious. However, if you live in a coastal area with strong winds, the payback period can be shortened to under 10 years. The story is not just about money, but about true year-round energy independence. This is when the hybrid formula appears to completely change the home energy game. The truth is that solar energy has a fatal weakness, which is its cyclical nature and total dependence on weather. In winter, when solar panels operate at their lowest efficiency, it is also when wind currents are strongest and most stable. Similarly, while solar energy peaks during the day, wind often blows much stronger at night. By combining the Archimedes turbine with a solar power system, you create a perfectly complementary power generation profile. Real-world data shows that a hybrid system can increase energy self-sufficiency from 61% to over 92% per year. This means you almost completely sever the link with electricity bills from energy companies. But before you order a turbine, there is a legal and technical maze that you must navigate through. Installing a device weighing from 100 to nearly 300 kilograms on a roof is not as simple as installing a flat panel. You will need a structural engineering certification to ensure that the roof trusses can bear the long-term load and vibration. Fatigue stress from micro-vibrations can cause serious cracks in the house structure if not carefully calculated. In addition, homeowners associations are often the biggest barrier, with strict regulations on aesthetics and noise. Unlike solar power, which is protected by energy access laws in many countries, small-scale wind is less prioritized. You may face local planning board hearings just to prove this device does not cause shadows or noise. Another difficult problem is the very thin professional installation network for Archimedes wind turbines currently. While you can easily find hundreds of solar installers, very few are knowledgeable about this spiral wind system. Most current Liam F1 owners are technically savvy individuals who perform DIY installations. Self-installation requires you to have solid knowledge of three-phase AC systems and MPPT charge controllers. If load management is poor, unwanted electrical surges can cause fires or damage the entire expensive storage system. Therefore, the first step is not buying equipment but performing a wind audit at your specific location. The energy available in wind is proportional to the cube of its speed, so a small error leads to a big failure. Just a 20% difference in average wind speed can result in a 72% difference in power output. You need to install an anemometer at the exact location and height intended for the turbine for at least 3 to 6 months. If the average wind speed at that point is less than 10 miles per hour, investing in this turbine will not be economically effective. The ideal installation location must be at least 3 to 5 meters higher than the highest point of the roof or surrounding obstacles. This helps the turbine escape the boundary layer of turbulent air that forms around built structures. A turbine placed too low in the swirling air zone will only produce a fraction of its rated power, regardless of the wind resource. Once wind potential is determined, the next step is choosing the right model for the family's storage needs. The Liam F1 line is the flagship commercial product suitable for directly powering heavy household appliances. Meanwhile, smaller models like the AWM 750D are excellent choices for charging batteries for off-grid cabins or streetlights. Beware of cheap spiral turbine imitations rampant on mass-market e-commerce sites. These units often use cheap plastic and undersized generators, leading to failure after only a few months of use. They completely lack the aerodynamic investment of the genuine Archimedes design studied for decades. Electrical integration also requires specialized components, like a wind-specific MPPT charge controller to manage variable input. An indispensable component is the dump load used to dissipate excess energy as heat. When the battery is full, the dump load prevents the turbine from overspeeding beyond structural limits, which could explode the device. For storage systems, lithium iron phosphate batteries are currently the top choice for wind energy systems. They are much better at handling inconsistent charging pulses than traditional lead-acid batteries. The battery management system also needs to be strictly set up to protect cells from sudden voltage spikes during gusts. In terms of maintenance, the Archimedes turbine requires periodic care but is not too complex compared to other machines. Bearings need to be inspected and lubricated annually to ensure the rotating shaft always operates smoothly. Blades also need to be cleaned of dirt or ice buildup as they can unbalance the rotor. The braking system, including electromagnetic and backup mechanical brakes, must be thoroughly tested before each storm season. The combination of a 2000-year-old geometric principle and modern storage technology is opening a new era. An era where each household is no longer a passive customer but an independent energy production unit. Despite the high initial cost, the peace of mind of having continuous power in all weather conditions is priceless. In the next part of the video, we will dive deep into the detailed wiring diagram for a true hybrid system. I will guide you on how to calculate backup battery capacity to maintain operation during weeks without wind. At the same time, we will also review real performance reports from users who have successfully installed it. Each rotation of the Archimedes spiral not only generates electricity but is a testament to the endurance of human intelligence. Let's explore how even rotting sticks can become a massive energy source in the next example. Now we will dive deep into the technical structure of the electrical system so you can have an overall view of the installation. The heart of the system is a three-phase AC generator using permanent magnets integrated directly into the rotating shaft. This alternating current cannot be charged directly into the battery but must pass through a three-phase bridge rectifier to convert to DC. From the rectifier, the current enters a smart charge controller, where the voltage is refined to match the battery bank parameters. An important difference is that wind charge controllers must have an electromagnetic braking feature to protect the turbine in strong winds. When wind speed exceeds the safety threshold, the controller creates an electromagnetic drag to actively slow down the rotor. Simultaneously, solar panels are connected via a separate MPPT charge controller to optimize energy from light. Both energy sources will flow into a single battery storage system, creating a more stable and continuous charging current. To calculate battery capacity, you need to list the total power consumption of all household devices per hour. Typically, a modern home needs at least 15 to 20 kilowatt hours of storage to maintain operation for 2 days without a charge source. With a hybrid system, you can reduce battery capacity because the ability to charge occurs almost day and night. Consider a real-world report from a household in coastal Oregon, USA after 1 year of using this system. During stormy winter months, the Archimedes turbine contributed up to 75% of the total electricity production for the house. Conversely, during the scorching summer, solar panels carried most of the electrical load for the cooling system. Average annual results showed they only had to use the grid for fewer than 30 days of extreme weather conditions. Another report from a small farm in the Netherlands shows incredible durability of bearings after 5,000 hours of continuous operation. They only needed to replace the grease once, and there were no signs of serious mechanical wear on the blades. For those who want to undertake this project themselves, the most sincere advice is to start with small-scale systems. Installing an AWM 750D turbine to light a garden or charge handheld devices is the best way to get familiar with wind technology. Once you have mastered the principles of load management and electrical safety, you should upgrade to the high-power Liam F1 line. A common mistake for beginners is using wires that are too small for the distance from the turbine to the controller. Voltage drop on long lines can lose up to 20% of the precious energy that the turbine just worked hard to create. Always use copper wire with a large cross-section and careful protective cladding to resist outdoor environmental impacts. The grounding system is also an indispensable part to protect the whole house from the risk of lightning strikes on the turbine pole. The grounding rod must be driven deep into the ground and tightly connected to the metal support frame of the device. In addition to technical factors, you also need to consider shadows and the flicker effect when the turbine rotates under sunlight. Although the Archimedes turbine is a solid mass at certain angles, it can still create flickering shadows on neighbors' windows. Talking to those around you beforehand and presenting the benefits of clean energy will help avoid unnecessary complaints. Many people worry that home insurance will be affected when installing an unfamiliar device on the roof. Proactively contact your insurance agent to update the status of your property and ensure everything is legally protected. The future of Archimedes wind turbines is expanding to larger-scale applications such as integration into skyscraper architecture. Architects are starting to incorporate wind spiral grooves into the facade design of buildings to utilize upward vertical airflow. This could turn skyscrapers into massive self-sufficient power plants right in the heart of the city. Large-scale 3D printing technology also promises to help reduce the production cost of spiral blades to more accessible levels. Instead of complex molding blades, can be precisely printed using super durable and lightweight composite materials. As costs decrease and installation networks develop, we will see an explosion of urban wind energy in the coming decade. Not just stopping at electricity, the Archimedes turbine also inspires generations of young engineers about the power of natural geometry. The combination of the golden ratio and aerodynamic efficiency is a valuable lesson in how we learn from nature. In the final minutes of this video, I will share with you a list of reputable component suppliers and technical support forums. You are not alone in this journey to conquer clean energy, because there is a global community always ready to help. Carefully check the technical specifications on the machine label and request quality inspection certificates before paying. Don't forget that our ultimate goal is to create a sustainable lifestyle and minimize our carbon footprint on Earth. Each kilowatt-hour you generate yourself is a small step toward a greener and cleaner planet for future generations. Now take out a pen and paper to record the most important connection diagram I am about to present on the screen. Note that these parameters may change depending on your geographical location and the specific climate of your area. If you find it too complex, do not hesitate to seek support from local electrical engineers to ensure absolute safety. A good energy system is one that operates quietly, durably, and does not cause any worry for the owner. We have come a long way from Archimedes pumps to the modern power-generating machines of today. The wisdom of the past, combined with the technology of the future, is the key to solving the current energy crisis. Join me in taking the first steps to turn your home into a true energy fortress. The diagram you see on the screen is the most optimized configuration for a home hybrid energy system. Pay attention to how blocking diodes are installed to prevent current from the battery flowing back to the solar panels at night. The entire control center should be placed in a fireproof electrical cabinet with good ventilation to avoid overheating. Temperature sensors attached to the battery bank will help the charge controller cut off the current immediately if an anomaly is detected. For areas frequently prone to major storms, you should install a tilt-down tower for easy maintenance. Lowering the turbine before a storm hits is the smartest way to protect your assets, even though the Archimedes design is very durable. Let's look back at the economic efficiency summary after 5 years of use between a solar-only system and a hybrid system. The hybrid system not only generates more electricity, but also helps extend the lifespan of storage batteries through regular charge-discharge cycles. Because the batteries are never discharged too deeply on sunless nights, the lithium cells retain their capacity longer. Energy independence also brings a great spiritual value, which is absolute peace of mind amidst global fluctuations. Whether the grid fails or fossil fuel prices escalate, you will always have enough electricity for essential needs. This is the concept of an energy fortress that we are aiming for in the new era. You can start with a small budget by utilizing old components or purchasing used equipment. Many renewable energy forums are great places to find affordable charge controllers or generators. Remember that every step, even a small one, contributes to the global green energy revolution. Don't wait until electricity prices become too expensive to start looking for solutions for your home. Be the pioneer in your community, bringing Archimedes spiral technology back to reality. We have seen the magic of ancient mathematics when combined with the human desire to protect the planet. This video hopefully has provided you with enough knowledge and motivation to start your first project. If you have any questions about calculating loads or choosing components, please leave a comment below. I and the community of clean energy enthusiasts will always be ready to answer and support you. Don't forget to hit subscribe and share this video with those who are also craving energy freedom. The power of the wind is endless, and how we harness it will define our future. Look out the window and feel the wind blowing by. That is an untapped resource. The first Archimedes turbine on your roof could be the start of a life-changing journey. Thank you for joining me throughout these 30 minutes of exploring this deep knowledge. All documents and technical diagrams have download links in the video description. Good luck with your energy project and soon achieving the goal of 92% electrical self-sufficiency. See you again in the next technical analysis and world-changing invention videos. Now go ahead and start building your own energy fortress today.